because we are starting a bit late, so maybe 15 minutes for the presentation, and we'll have 5 minutes for questions. Okay, please go ahead.
Thank you. Greetings, everyone. My name is Fiska, and I'm about to present you the overview of uPrevent project, a smart insole for diabetic foot ulcer prevention. According to the World Health Organization, diabetes mellitus affects around 422 million people globally and is directly linked to approximately 1.5 million fatalities per year. Diabetic foot ulcer is one of the most prevalent and serious complications among diabetics. In fact, every 30 seconds, a lower limb is amputated owing to diabetes, which is also raising fatality rates. Diabetic foot ulcer is not only a patient issue, but a serious health concern worldwide. Infection treatment in diabetic foot ulcers is challenging and costly. The objective of the uPrevent project is the design and development of a smart insole that will automatically redistribute foot pressure in diabetic patients to prevent diabetic foot ulcers. This study describes the uPrevent project's approach to developing a smart insole technology to prevent diabetic foot ulcers. It includes the description of the architecture of the uPrevent prototype insole and the integration with a software AI-enabled counterpart of the system. The uPrevent project consortium consists of partners from research, academia, medicine, and small medium enterprises located in various areas around Greece. The diagram on this slide presents the uPrevent system data and decision flow across the whole platform. The architecture of the end device consists of pressure sensors and actuators. The plantar pressure data recorded from this device are sent to an external computation management AI component for the computation of the redistribution of the plantar pressure areas. This result is then sent to a data process, to an application platform for data process, and also providing also a user interface for both patient and doctor to be able to monitor patient status, and for the doctor specifically to be able also to intervene in the redistribution decision if necessary. This final outcome is then sent again to the end device, triggering the actuation system in order for the high risk plantar pressure areas to redistribute the pressure, like the metatarsal head and heel. The following diagram illustrates the higher level of the uPrevent web platform. As said earlier, the pressure measurements from the device are provided to a web application, which is responsible for the data management, for the data collection, management, and visualization. You may see also an example of the pressure distribution from before the recording and after the recording and after the triggering of the actuation. The initial uPrevent prototype consists of a metal surface insole and bonded nuts redistributing thread morphology by modifying screw height. An involved prototype consists of a thick silicone thread surface with an integrated maze for the adjustment of the axis, the selection of the thread surface areas, the connection to a specific number of axes, and the selection of stepper motors adjusting with the shafts for automated adjustment of the areas in order to optimize the surface pressure. While the integrated insole system allows for sensing and changing, its integration as part of a larger AI-enabled system will enable intelligent decision-making. Personalized insole geometry will consider general best practices and thresholds exceeded, but also computational models of patients through trials. The platform will enable patients to self-manage their condition and doctors to remotely monitor and take timely decisions by viewing the metrics. In conclusion, the uPrevent project proposes a smart insole prototype for foot ulcer prevention in diabetic patients that combines pressure sensors, actuators, and intelligent decision-making. The uPrevent insole device aims to alleviate treatment costs and deliver effective and timely prevention for diabetic foot ulcers by allowing an affordable and objective way for patients to monitor their condition remotely and continuously. The references mentioned during this presentation are listed to this slide. That was it. Thank you for your attention.
Thank you very much, Vicky. Are there any questions? Can we see whether there are questions from the audience? No. Okay, so Vicky, can you please tell us the current status of the project? So in which phase is currently the project?
Sure. Actually, we are currently developing the second prototype of the device. The initial prototype is completed. We're working on the second prototype of the device. And also at the same time, in parallel, we work on the web application platform development and the data collection, the communication between these systems in order to establish the communication we need to proper process the data with the AI algorithm.
Okay, thank you. And maybe some information about the challenges faced so far. So they were mainly concerning, for example, the data collection, the actual development of the system, the patient's participation, all of them.
Yes, okay. Well, I will take it in order. So the main challenge is the construction of the Insole device. And especially to have accurate, timely, in time and in space actuation accordingly. So this is the main challenge of the project, maybe the biggest one, but also the most exciting part. And according to the data collection, it's not such a challenge because we use a commercial sensor Insole that is providing the data in the format we need in order to process it. Right now, we are in research of the AI algorithms that may fit best to our solution. We haven't concluded to this yet, but we are working on it. And the correct visualization in the platform is also a challenge. We need to provide the best way possible the information for both patient and doctor in order to be for the decision-making process to be correct for them too.